Hey, what's up, guys? Welcome back. I am going to go over that constant acceleration lab. So we got this back the other day. I haven't had a chance to make a key and go through it. So we're going to do that now. Um, Good refresher. So if you remember when you did this lab, the concept was you wanted something rolling down a ramp. And it needed to roll down that ramp the whole time. So if it were doing that, if I had a ball up here at the top, then this ball would go from rest, 0 meters per second, to speeding up the whole time. And so it should be fastest at the bottom there. And I think you guys would know that. But if you're thinking about what should happen here, that's kind of the key for all of this. So we talked about in class, what should have been true for these velocities here. And when I looked at your data, these should have been increasing. As your distance increased, the velocity should have increased. And if it didn't, then that most likely you didn't have a perfectly straight ramp. Could be one source of error, or you might have mistimed things. So those are common errors. Some of us are still having a hard time with our average time. So remember, when you do the average time, you add these three up, whatever you got here, and you divide by 3. So that's how you'd get the average time. Average velocity is the distance over the time. But we were overall pretty good on that part. Then the graphs there of your own, we're getting better at that. Remember that time goes on the x-axis. Some of you have got to figure out how to put a trend line in equation. And so if you're still struggling with those graphs, you've got to go back and watch the short video that I made. I think it's under 4 minutes. And it makes it pretty easy. But we've talked about that a lot in class now, so hopefully we're doing okay. So it's really just these lab questions that we want to go through is the main part of this. So first thing says, what is true about the velocity of the ball bearing as it goes down the track? So I did have some kids who were confused about ball bearing, and I apologize. That's kind of what I've called them, the marbles or the steel balls that I use in class. So if that confused you, sorry, don't let it confuse you in the future. I forgot to edit that part out, but just meant the ball that you used. So what is true about the velocity of the ball as it goes down the track? That is, the velocity should have increased. And typically, if we do this lab right, we absolutely get that to happen. And then here, if the velocity is changing, what I just want you to understand is kind of a definition type question. If the velocity is changing, then that means that the ball is accelerating. So you gave me some varied answers in there and stuff, but I just want you to know that if we have a velocity change, that's an acceleration. Then here, I think everybody got this one right, but if you used a steeper track, what would happen to the value of acceleration? So if I went from something like this to something like this, then acceleration would be greater. So it would speed up faster on a steeper ramp. Then here, this is where we got to understand some of the words and the way that what the question is asking. So it says the acceleration should be constant for this lab. What does this mean in terms of the change in velocity for each time interval? So here's, kind of definition-wise, if it's a constant acceleration, like in most classes, we use the constant acceleration when we went over stuff of 20 meters per second. And so what does that mean in terms of the change in velocity for each time interval? And here's where I needed you to word this kind of specific to that. And so what that means, if acceleration is constant, is that the change in velocity is the same for each interval. So like in 1 second, it goes up by 20 if I'm using this, and then the next second it goes up by 20, and the next second it goes up by 20. So I have like down here, and then we see that down with this next question, because I give you a data chart to get you to hopefully think about that. And so here, which one shows a constant acceleration? So that's the one where the velocity is going up by 5 each time interval. So that's a constant acceleration of 5 meters per second per second. So it keeps going up. Some of you answered that this one showed a constant acceleration, and what you're confusing there is you're confusing constant velocity with constant acceleration. And so what you've got to think about in your head is if it's a constant acceleration, then that means the velocity changes the same each time interval. And then along with that, so we have if acceleration is constant, what's happening to the distance covered each second? So you guys can think this through, but it just, you're putting all these terms into the right place. So if acceleration is constant, it means I'm going faster and faster. So that means that in terms of distance, I'm covering more distance each time interval or each second. And so the reasoning behind that is because you're going faster. So that helps you hopefully understand that. We've talked about that several times in class. And then I asked you about theoretical position time graphs and velocity time graph for those. And that was thinking about what your graphs ideally up here had looked like. They didn't look perfect, but they looked okay for the most part. And that kind of came straight from our notes where, you know, we had these two graphs for the distance versus time. So I'm just going to cut or copy this and put it into our key here. Oops, we don't want to call that number 8. But it would look like this because I'm covering more distance each second. That takes this shape. And then let me cut and paste this one. Copy and paste. And so here is this one. And so the theoretical velocity time, this gets back to this question up here. The change in velocity is the same for each time interval. So that means that every time interval, my velocity goes up the same amount, and that gives me a line with a positive slope in this case because acceleration is positive. And then here, as we move to number 9, what does the slope of our velocity versus time graph show? So if I found the slope of this line right here, slope is change in y, change in velocity over time, change in x. So the slope of a velocity time graph is acceleration. And so, you know, you've got to start to know that. Some kids are like, I don't know what this question means. In which case, if you're looking at a question and you don't know what it means, then you want to reach out for some help so I can clarify that for you. And then what was the slope of for your line on your velocity time graph? So that just came from you finding the trend line and the equation, and then you would get, just like we talked about in class, you get y equals mx plus b. You get that in that format, and you've just got to then figure out that just the m is the slope. So, you know, report that. And you could now start to think about if slope is acceleration, then the units for that are meter per second, or meter per second squared. So you could think about if you give me the number, you can start to add units to it to really show me that you understand. And then the last question had to do with, I'm just going to move this down, oops, so it can all be on the same page. Insert a page break. So the last question had to do with these two graphs. So this is what we spent a lot of time on this week. But in terms of the motions, so here I would say for G, whoops, I don't like that. Maybe I'll do it up top here. So for G, because this is position time, so that's what's key is, remember, being able to read these axes. So position time like this means that I go away from where I started, my position goes up, my position doesn't change, and then I come back to where I started. So what, in terms of motion, you could say the object or person, whatever you want to call it, is moving away, then they stop, and then they return to where they started. Now, best answers would be that they move away at a constant rate or constant velocity, stop moving, and return at a constant rate or constant velocity. So that would be a really great way of doing it. But if you said it like this, I'm very comfortable with that. And then for H, what is happening here is the object starts with some velocity, and then that velocity keeps decreasing until 0. So you could say that the object is moving at some velocity or speed and slows down to a stop. And that's perfect. That is a negative acceleration. It's not the same thing as a negative velocity. So one thing that I want you to be able to realize is the whole time velocity is positive. It's above the x-axis. So that means the object is moving forward in a positive direction, but just slowing down. So hopefully this helped clear some stuff up. And if it didn't, or there's still things you're confused on, please schedule time to meet with me, because I like to talk about physics and glad to help you understand.